In civil engineering, every structure, from the tallest skyscraper to the longest bridge, must withstand a variety of forces, known as loads. Understanding these loads is key to designing safe and durable structures. In this video, we'll break down the 4 main types of loads engineers consider: dead load, live load, wind load, and seismic load. The first type of load we'll look at is the dead load. Simply put, the dead load is the weight of the structure itself. This includes all the permanent components like walls, floors, beams, columns, and the foundation. Because the dead load doesn't change over time, it's one of the most predictable forces. Engineers carefully calculate the weight of every material used in construction, from the steel framework to the concrete walls, ensuring the structure can support its own weight without buckling. For example, in a concrete building, the dead load includes the weight of the concrete slabs, beams, and columns, along with permanent fixtures like ceilings and windows. These elements are constant throughout the structure's life. Next is the live load, which refers to the temporary or movable forces that a structure experiences. This includes the weight of people, furniture, vehicles, and other objects that move or change position over time. Unlike dead loads, live loads are variable. For example, a bridge must be able to support heavy traffic during rush hour, while a stadium must handle the weight of thousands of spectators. In buildings, live loads account for occupants and their activities. Live load calculations are based on the expected use of the structure. A residential building has lower live load requirements compared to a commercial office or a stadium. Engineers add a margin of safety to ensure the structure can handle fluctuations in load. Structures don't just carry their own weight, they must also withstand forces from nature, such as wind. Wind load refers to the force exerted by wind on a building or structure. Tall buildings, bridges, and towers are particularly vulnerable to wind loads. Engineers must design these structures to resist lateral forces caused by strong winds, which can create pressure on one side and suction on the other, leading to sway or even collapse if not properly accounted for. Wind load calculations take into account the height of the building, its shape, and its location. Buildings in hurricane-prone areas, for example, are designed with extra reinforcements to withstand extreme wind speeds. Special features like windbreaks, aerodynamic shapes, and flexible materials can help reduce the impact of wind loads on tall structures. Finally, we have the seismic load, which refers to the forces generated by earthquakes. Earthquakes cause the ground beneath a structure to shake, creating powerful lateral and vertical forces that can be catastrophic if not properly designed for. In areas prone to seismic activity, like California or Japan, buildings are designed with earthquake-resistant features. This includes flexible materials that can absorb the energy from seismic waves and prevent cracks or collapse. Seismic loads are unpredictable, but engineers use historical data and simulations to anticipate the worst-case scenario for a given location. Special design techniques, like base isolators and shock absorbers, are used to minimize the effects of seismic activity. For example, the Taipei 101 tower has a massive tuned mass damper, a giant steel ball suspended inside the building that helps counteract the swaying motion caused by earthquakes or strong winds. To ensure a structure's safety and durability, engineers must account for a variety of loads: dead loads, live loads, wind loads, and seismic loads. Each of these forces plays a critical role in shaping the design and construction process. Understanding these loads is essential for anyone interested in civil engineering. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell to stay updated on more civil engineering content. Thanks for watching, and see you in the next episode.